Hey all, at the beginning of the year we talked about what meant to be congruent and congruent angles and congruent segments, and today we're going to talk about what it means to be congruent polygons. So there's two conditions that need to be satisfied if two polygons are going to be considered congruent. One is that their corresponding sides are congruent, and two is that the corresponding angles in the polygons are congruent. So remember that being congruent means that you're the same size and the same shape. So in order to be congruent polygons, they need to be the same size and the same shape. And after they're the same shape, we can determine they're the same size by seeing if these two conditions are satisfied. So let's talk about the word corresponding that is in each of these statements. To determine which angles correspond and which sides correspond, we're just going to look at the names of the polygons. So let's start with angles. In these two quadrilaterals, the first letter that appears in the name is A and L. So angle A in quadrilateral ABCD is congruent or corresponds to quadrilateral LMNO angle L. So let's find L and A, and they are the same size, so they're congruent. B and M are the second letters, so they're corresponding, and they are congruent as well. Angle C and angle N correspond. They're in the same place in the name. They're also the same measure, so they are congruent. Angle D and angle O correspond, and again, they're the same measure, so we have all four corresponding angles to be congruent. And we found that they're corresponding just by looking at the location of the angle name in the polygon's name. So let's do the same thing for the sides. We can actually do a similar thing. A and B are the first two letters in ABCD. L and M are the first two letters. So I can actually draw a segment symbol over top of those, and I can see that segment AB and segment LM correspond. AB is 5 inches, LM is 5 inches, so they're congruent. BC and MN are in the same spot, so they correspond. And they are also the same size, so they're congruent. CD and NO correspond. They're the same size, so they're congruent. And last but not least, AD, the first and last letter, and LO, they correspond to each other, and they're also congruent. So I have 4 pairs of corresponding congruent angles and 4 pairs of corresponding congruent sides for these 4-sided, 4-angled figures. So I can say that they are congruent quadrilaterals. So knowing how the names work and how they tell you about the angles on the sides, if I have 2 pentagons, so 2 5-sided polygons, and I know they're congruent, I don't even need to see their pictures. I can just look at their names and know which angles should be congruent and which sides should be congruent. So I see that H and Q are the first letters in these pentagons, so angle H is congruent to angle Q. Angle I is congruent to angle R. Angle J is congruent to angle S. Angle K is congruent to angle T. And angle U is congruent to angle L. Oh, and I did that backwards, I apologize for that. If I'm being consistent, I should say angle L is congruent to angle U. So again, all I did was look at the location of the letter in the name of the pentagon. So H is first, Q is first, they're congruent. L is last, U is last, they're congruent. I'll do the same thing with the sides. HI are the first 2 letters, QR are the first 2 letters. So segment HI is congruent to segment QR. Segment IJ is congruent to segment RS. JK is congruent to ST, and I can just keep going just by looking at the position of the letters. K and L, the last two letters, congruent to TU, and then HL, the first and last letter, congruent to QU. So the names really speak volume to what is happening with these two pentagons. So if I were to draw these two pentagons, HIJKL and QRSTU, these would be the pairs of angles and the pairs of sides that correspond to each other in order for them to be congruent. So go ahead and pause here, and I want you to write down the names of the corresponding angles and the names of the corresponding sides in these two congruent hexagons. So we have 6 angles and 6 sides in these two hexagons, so you should have the 6 angle pairs congruent and the 6 side pairs congruent, and that's all based on the location of the letters in the name. So A comes first in ABCDEF, L comes first in LMNOPQ, so A and L are congruent. Same thing for segment AB and segment LM, those two sides are congruent, so on and so forth. So check your answers there. We can also use this information to do some algebra, find some angle measures, find some side measures. So here I have 2 congruent quadrilaterals. One has all the angles labeled and one has an expression. So angle G is the angle I'm interested in, 4x plus 10. And if I look at the names, G corresponds to O, which right here is 94 degrees. So I know that those two angles are corresponding. They're congruent because the quadrilaterals are congruent. So I can say that those measures are equal. And now I just have an equation to solve. And I get that x is 21. So that means when these two angles G and O are congruent, x is 21. I can plug in 21 to make sure that I'm right. 4 times 21 is 84, plus 10 is 94, and that will be the same as angle O. So go ahead and pause here, and I want you to find the value of x with side LM labeled 7x minus 2. And these two quadrilaterals are congruent to each other. So here, segment LM corresponds to segment TU. Because the quadrilaterals are congruent, that means those sides should be congruent. That means they should be equal. So I can take those two side measures and set them equal and get that x is 2. If I plug 2 back in here for 7x minus 2, I get 14 minus 2, which is 12. So I want you to try these two, and I want to highlight something for you here. I use this symbol that looks like a triangle in each of these because that's the symbol that we use to represent triangle. So each of these polygons that I'm naming in these two examples are triangles. They have 3 sides, 3 angles, so there's 3 letters in their name. And instead of writing the word triangle, we can just use this symbol that is a triangle. So from now on, when you're naming a triangle, you can use that to name it. So try these two, and we will talk about them in class.